It's recording on my end, representing benchmark fractions and percents. Okay. Use the understanding of fractions to list two equivalent fractions for the problems below. So we're not changing these to percents. We're just listing two equivalent fractions. That means they can equal each other. So we can reduce or we can enlarge. If I reduce this, that means I'm going to go smaller, so I divide by 2. 6 divided by 2 is 3. 9 divided by, oh, can't do that, so let's do 3. We're going to divide by 3 instead. So 6 divided by 3 is 2. 9 divided by 3 is 3. So 2/3 also equals 6/9. Now then, if I enlarge it another time, I can go, let's multiply by 2. 6 times 2 is 12. 9 times 2 is 18. So there's my two equal fractions, or equivalent fractions. Okay, so let's do it again on the next one. If I divide by 2, I can make it smaller. 8 divided by 2 is 4. 10 divided by 2 is 5. If I want to go larger, multiply by 2. And 8 times 2 is 16. 10 times 2 is 20. So all of these are the exact same. This one, your like a slices of pizza or cake or pie, these slices are going to be a lot bigger because there's 4 out of 5. This one, same pie, but you're going to have 8 slices. So they're all equivalent. So when you put them together, they're going to equal the same. Okay, this one is a mixed fraction, but we can still make it larger. We can't make this one smaller, but we can make it larger. So if I'm going to multiply by 2, 5 times 2 is 10. 4 times 2 is 8. Okay, I can multiply this again by 2. 10 times 2 is 20. 8 times 2 is 16. So to make fractions equivalent, you can divide them to make them smaller or multiply them to make them larger. Excuse me. All right. How do the fractions you wrote compare to each of the original fractions? Well, they all represent the same value. They all represent the same value. Okay, if I were to make those decimals, all 3 decimals would be the same. If I turn this into decimals, all 3 decimals would be the same. If I turn these into decimals, all 3 decimals would be the same. So the value has not changed. A fraction can be written as a percent when the denominator is a 100. 100 will represent the whole pie, the whole pizza. So percents will always be over 100. That's what we compare them to. If the denominator is a friendly number, friendly, and I always call it pretty, you can scale up or down or use a proportion. Okay, so to multiply what times 2 gets me 40. If I multiply by 20, I'm going to get 40. So I have to multiply the bottom the same way. 5 times 20 is 100. Same thing with this. 2 times 20 is 40. 5 times 20 is 100. And this is something that you should have already known. This should be a review. Okay, so convert each fraction to a percent by making the denominator 100. So it wants you to make it into 100. So 20 times what will give you 100? 20 times 5 gives you 100. Well, if I do it to the bottom, I have to do it to the top. So 6 times 5 is 30. So it's asking for a percent, but first you had to make the denominator 100. So now that we have 30 over 100, your percent is 30. It's wanting you to show your steps so that we understand that you know how to get there. If you're understanding it, great, but I still want you to show your steps. Okay, so I've got to make this 100. 10 times 10 is 100. 7 times 10 is 70. So your percent is going to be 70. I hope this is coming back. Okay, now then we need to do this one into 100. So 4 times 25 equals 100. Do that to the top as well. 3 times 25 is 75, which would be 75%. Again, this is review. So, you have the fraction, 3/10. I want to put that over 100. Every single one of these is over 100. So how did 10 get to 100? Multiply by 10. Multiply by 10, you get 30. So now that we have it over 100, it is 30%. 50 times 2 equals 100. 35 times 2 is 70. Gives you 70%. Once it's over 100, you have your percent. Percent is always over 100. So again, 20 times 5 is 100. 19 times 5 would give you 95. So your percent is 95%.
Layla Howard, please report to the office to leave. Layla, please come by the office to leave.
Okay, so we're doing the next table. So again, it wants you to solve these, put them by over 100 first, and then make them into a percent. So 25 times 4 will give you 100. So 8 times 4 should give you 32. 50 times 2 would give you 100. So 60 times 2 will give you 120. 20 times 5 will give you 100. So 13 times 5 is 65. This is where you're going to make sure you're listening because I'm not writing it down. And then I'll take this and just make them into percents, just like we did here. Okay, so that's on you. It shouldn't take you very long. Okay, tape diagrams and numbers. This is not one of my favorite things, but we have to teach it and you will be tested on it. But if you can solve it another way to find out what your answer is, that's fine too. Because there's more than one way to solve a problem. All right, not all fractions can easily be multiplied by a whole number to get a denominator of 100. For example, 1/3. 1/3 is a benchmark fraction. Hopefully you've memorized that one to be 0.3 repeating. Okay, that's a benchmark fraction that you need to memorize. Divide the tape diagram or number line into the same number of sections as the denominator. Shade the number of parts indicated by the numerator and estimate the value. So again, they're throwing some vocabulary out there that you have to know, and you should have already learned that your denominator is always on the bottom and your numerator on a fraction is the top number. So on your fractions, numerator, denominator. If you can't memorize that, just remember D for down. The number that is down is your denominator. Okay, so we have an example of 1/8 is equal to what percent? So we need to divide this into eighths. Okay, so I'm not good at dividing things, but you're going to divide them into 8 parts because your 8 is 100%. And I only want to know what is 1/8. That right there is 1/8. So I would need to know how many parts does each square represent. Okay, so if this is 1/8, 2, 3, 4, 5, 6, 7, 8 parts. And if I know 4 is half of 8, so that would be 50% there, which is half of the tape, because that would be 100%. So now then I can go, oh, well 2 is half of 4, so 2 would be 25%. So what would that make this right here be? Well, it's halfway between 0 and 2, so I would half 25. So that's going to give you a 12.5%. So that's going to equal 12.5%. Same thing with the tape measure here. Same thing as we just listed as above, 25. And then to get halfway between 0 and 25, we half that, and we figured it was 12.5. Okay. I would rather set it up as a proportion because we've learned proportions and we know how to do that. If we could do 1/8 and we knew it was over 100, we could solve it like that and do cross product. This is my method I would prefer. Some people are visual and like to draw it out. So either way, which works for you, is fine. But you will be tested on both ways. I can't promise what they're going to throw at you, but you need to know how to do them both. But as long as you can get to the answer, then you can figure out the answer on the diagram. All right, create a tape diagram or number line to determine the equivalent percent. 1/3 is equal to what percent? Well, we need to divide that into threes. So that would be 1, 2, 3. It's very not proportional. And since we already stated that's a benchmark fraction, I know that 1/3 is 0.3 repeating. To make that to a percent, go 1, 2, and since it's repeating, that's going to be repeating threes. So that's going to be 33.3 repeating percent. Now, is that the way they want you to do it? No. But to me, it's the easier way to do it. Okay, so let's look at number 8. 3/8 is equal to what percent? Okay, so if we have, again, we're going to make it to 8. I'm just going to use this one right here because I really can't. Well, that would be 50 right there about. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And we know that from up here, 1 is 12.5%. And it's wanting 3/8. So if I wanted 3/8, that would be 1, 2, 3. How much is this right here? Well, if I know each one is worth 12.5, I can multiply that by 3, and you're going to get 37.5%. Because I know what my single unit is right there. Nope. So 1/5 is equal to what percent? So again, we need to break this down in fifths, which is 1, 2, 3, 4, 5. Again, it's not proportional. So how much would each of those be? Because of money, I can tell you 20 cents, all these are going to be worth 20 cents. Because 5 times 20 is 100. So this one right here is going to be 20%. Taking what I know from previous lessons or previous years that you've learned and applying them to this one. Okay, so 1 2/3 is equal to what percent? Well, because we have a whole here, this whole number right here means this whole bar is shaded in. You've got over 100% right there. So 1, 2. That whole bar represents your whole number right here. Now the second bar is going to represent your 2/3. Okay, so again, what did we say 2/3 was? We did it right there, or 1/3. 1/3 is 33.3 repeating, because 1/3 is 0.3 repeating and 2/3 is 0.6 repeating. So that would be 0.6 repeating. Change that to a percent, and you're going to get 66.6%. So again, this is some benchmark fractions you should already know. We're just reviewing them, taking what we know previous. All right, let's look at the back side. Representing benchmark fractions and percents. Use your understanding of tape diagrams and number lines to model percents below. So 3/5 is equal to what percent? So again, we're going to divide this into fifths. It's 1, 2, 3, 4, 5, with 5 being your 100%. Okay, so again, because I know my previous number facts, 100 divided by 5, each of these are going to be worth 20 to build up to 100. So if I take 3/5, if I take this right here, it's going to give me 60%. And again, I would prefer to set all this up as proportions, as 3/5 equals what over 100. It's cross product. To me, this is much easier than filling out a tape measure. So if this works for you, I would encourage you to do that. 1/10 is equal to what percent? Well, we can make 1/10 over 100 like we did on the front page, times 10 times 10, 10%. So to me, that's a lot faster than drawing it out, coloring it in, and doing all that. But if they're going to do it 1, 2, 3, 4, 5, that would be 50%. 6, 7, 8, 9, 10. That would be your 100%, 50%. And so your tenth would be 10%. Okay, number 3. Represent 5/8 on the number line. All right, so we have 0 here and 1 here. And it should be divided into 8. But it's 1, 2, 3, 4. They're only divided into 4. So I can either, I need to fix this where there's 8 parts to it, because there's 8 parts in the whole. So that needs to be 8. So 1, 2, 3, 4, 5, 6, 7, 8. I want 5/8. 5/8 is right here. And that's all you had to do is represent it. Say where it's going to be on the number line. Number 4, represent 5/6 on the number line. So again, we have 1, 2, 3, but we can easily divide that up into 6 parts because that's how many make a whole. And that would be your 1, 2, 3, 4, 5, 6. So just circle in where 5/6 would be on that number line, just like we did in number 3. Circle in 5/6. Number 5. Which of the following is true about the values below? Circle all that apply. Okay, all the values are less than 50%. Well, this one is 1/3. What did we say that was? 0.3. Change that to a percent. You're going to get 33.3%. So that one is, and 10% would be, it would be 10%. So yes, all of those are less than 50%. All the values can be represented by a percent. True or false? Okay, so can they be represented by a percent? If it's true, circle it. C, all of the values are greater than 10%. If that's true, write true or false, or just circle it. D, all the values are greater than 1. If that is true, circle it. Okay, and down here, we're going to do what we did on the front page. You're going to do them all over 100 and turn it into a percent. This one, you're working backwards. Okay, so remember, percents always go over 100. I'll do the first one with you. So if we're going backwards, 20 over 100. And now you want to reduce that to a fraction. Well, 20 can go into 100. So let's just divide this by 20. So 20 divided by 20 would be 1. 100 divided by 20 is 5. So you're just working backwards. Okay, when you finish that and you've shown all your work, make sure your name and date are on the paper and you can turn it in.